Thanks to rectangular coordinate systems, understanding vector addition becomes very easy. For two vectors a and b of the same dimension, vector addition means adding their corresponding components element-wise to generate a new vector. In the previous video, we mentioned that the RGB color model, adding red vector e1 and green vector e2 results in the yellow vector, and adding the red vector e1 and the blue vector e3 give us the magenta vector. Similarly, adding the green vector e2 and the blue vector e3 produces the cyan vector. And when we're adding all three vectors, e1, e2, and e3, we get the white vector. Now, how do we visualize vector addition? One way is to use parallelogram rule. When adding vectors a and b, we align their starting points. Then, treating a and b as adjacent sides of a parallelogram, the diagonal from their common starting point to the opposite vertex represents the vector sum a plus b. With this rule, we can construct a parallelogram where the red vector e1 and the green vector e2 form two adjacent sides. Then, align their starting points. Complete a parallelogram by drawing the other two sides. The diagonal from the shared starting point to the opposite vertex gives us the sum of e1 and e2, which is the yellow vector. Similarly, we can apply the parallelogram rule to find the magenta and the cyan vectors. Another approach to visualize vector addition is the triangle rule. For vectors a plus b, the triangle rule states that we place the second vector b so that its starting point aligns with the endpoint of first vector a. The resulting directed segment from the starting point of vector a to the endpoint of vector b represents their sum. Applying triangle rule to our RGB example, we can move the starting point of green vector e2 to the endpoint of red vector e1. The vector from the tail of e1 to the head of e2 gives us the yellow vector. Alternatively, we could shift red vector e1 so that its starting point aligns with the endpoint of the green vector e2. Then the resulting sum is still the same yellow vector. This demonstrates the commutative property of vector addition, i.e., adding e1 and e2 is the same as adding e2 and e1. Now let's extend this to three vectors. In the RGB color space, if we apply the triangle rule successively to red vector e1, the green vector e2, and the blue vector e3, the final vector points to white, meaning e1 plus e2 and e3 give us white vector. There are two different ways to compute this vector sum. One way is to first compute e1 and e2, which gave us the yellow vector, then adding the blue vector e3 leads to the white vector. The second way is to compute, firstly, e2 plus e3, which gave us the cyan vector, then adding the red vector e1 also gave us the white vector. This demonstrates the associative property of vector addition. e1 plus e2 grouped together first plus e3 is the same as e1 plus the sum of e2 and e3. Next video, we'll talk about scalar multiplication of vectors geometrically. It means scaling the original vector either in the same direction or in the opposite direction.